This is topic 4.3, rates of change other than motion. And we're going to jump right in to increasing or decreasing. To know if something is increasing or decreasing, all we have to do is check the sign of its derivative. Now you might be asking, well, what's it? Well, it is whatever you're wanting to know if it's increasing or decreasing. So, in this example, height. If we want to know if height is increasing if the derivative of height is positive. How about velocity? Velocity is decreasing if we take the derivative of velocity and find that it's negative, less than 0. How about someone's IQ? So, Mr. Bruce's IQ, the derivative would need to be positive for it to be increasing. And last, just to be kind of funny, but also it's important, smiley face is decreasing if the derivative of smiley face is less than 0. So those are good examples. Try to keep it simple. Whatever it is you're wanting to know about increasing or decreasing, just take the derivative and look at the sign. Okay, my calculator wasn't working very well, but I want to tell you two things. So I just took a screenshot of it. The first thing is this is not 3. Taking the sign of 3 is not something that we normally do. 3.14 for pi over 2, pi over 6. But when you see something like that, it's going to be on the calculator portion of your test or homework. So feel free, when a calculator is allowed, feel free to use that calculator. So I just wanted to recall the method. It is under Math 8. So you want to press the Math button and go to 8. And that's how you find the derivative. And over here is what we did. It brings up a menu. I had to type in x, and I also had to type in this function, and I had to type in the 3. Where did I want the derivative evaluated at? And so f prime of 3 is equal to negative. I'll put that Math 8 over here. And so f prime of 3 from the calculator is negative 1.999, or you could just say negative 2. So just a good recall of how to find the derivative on your calculator. Okay, let's go ahead and cover what our function actually represents, okay? So is the function you're already looking at, is it already a rate of change? Because if it is, then you're finding the rate of change of the rate of change. So let's look at this example. If f of x is the bunny population after x years, what is f prime of x? Well, f prime of x is the rate of change. Try to use those words. Rate of change of the bunny population per year. Okay? But what if f of x is the rate at which the bunny population increases? So f of x is already a rate. F of x is bunnies per year. Then what is f prime of x? Well, in this case, f prime of x is the rate of change of the rate of the bunny population per year. So it is a rate of change of a rate of change. Okay, let's take a look at this table, finding the rate of change from a table. Now, there are a couple things to note. Here we have T in years, and here we have people, okay? And so whatever it represents, it could be, I don't know, people that are part of a club after 0, 10, 20, and 30 years, whatever it might be. And if you were asked to estimate P prime of 15, you can see 15 falls right in here between 10 and 20. So P prime of 15 is equal to P of 20 minus P of 10 all over 20 minus 10. And that would be 150 minus 120 all over 10. And you'd come up with 3 people per year. Okay, so that wasn't too difficult because we had a year fall in between both of the data values. But what if you were asked to find, to estimate, and by the way, this is an estimate. I might have said when I was doing it equals, but it's just an estimate. So estimate P prime of 20. Well, you have a couple choices, and none of them are wrong, okay? None of these 3 are wrong. So for 20, you could find the rate of change between 20 and 30. You could find the rate of change between 10 and 20, and you could also find the rate of change between 10 and 30. So you have 3 choices, okay? All of them are correct if you show your work. So you could use P of 30 minus P of 10 all over 30 minus 10, or you could use P of 20 minus P of 10 all over 20 minus 10, or you could use P of 30 minus P of 20 all over 30 minus 20. So we could work all of those out. I guess I could go ahead and do that. So P of 30 is 200 minus 120 all over 20, and that would be 80 over 20, which is 40 people per year. P of 20 minus P of 10 would be 150 minus 120 over 20 minus 10, and that would be 30 over 10. I think this would be 4. Sorry about that. 4 people per year, and this would be 3 people per year, and that's actually what we used over there. Or P of 30 would be 200 minus 150 all over 10, and that would be 5 people per year. So all 3 of these are correct. What wouldn't be correct is using 0 to 30. We want to stay as close as possible to the data value that is being asked to be estimated. And that concludes this topic.